Okay, this is Marlies Ann Holmes. I'm a marine scientist and I want to clear up some difficulties that I have with the information supplied about the ENSO, Southern Oscillation, La Nina, El Nino. Now this is a marine-driven system that affects planetary weather and affects flooding. La Nina is what New Zealand's been sitting in, and Auckland's been flooded, and the eastern coast of Australia flooded, right? And the weather reports are sometimes a bit difficult to understand, so I thought I'll just put this out for people to have some information about where it comes from, what drives it. Now we've got surface currents in this map, but we've got deep water currents. Ice melts, it sinks, and from the Atlantic Ocean, from the ice cap, the deep water current comes down here and goes around the Southern Ocean, all the way around here. These are surface currents, and then it comes up here and travels west. That's the driving force for El Nino and La Nina. These are Spanish words, and it comes from a Spanish-speaking population, and it describes an oscillation between two sort of set arrangements, with the water flow from deep water currents, initially from the Arctic Ocean, the Arctic ice melt, that arrive and upwell and feed fisheries which are oxygen rich here. Now this cold current goes west and cools things down, or it doesn't go west, and so it's warmer. When it's warmer, you get more precipitation. When it's colder or warmer, you'd have to work that out. Right, up here you've got just a picture to help you understand. You've got deep water currents from the Arctic on the left there that can upwell. That's the idea. Cold sinks, travels, upwells when it hits the right place. Let's just go over here. So you've got Arctic ice melt, sinking, travelling, then going right round, all the way around, boom, all the way around, and then up here, and then west, or not so far west. It is cold and it cools the tongue of cold water, or it doesn't cool a tongue of cold water. And it changes at Christmas, and that's why it's La Nina and El Nino, because it's the child, it's the godchild, it's the son that is born at Christmas. And so that's why it's La Nina, because it often happens at Christmas that it twists into La Nina. From El Nino. El Nino and La Nina are Spanish. Let's look for Tahiti. Tahiti and the Cook Islands, French Polynesia, and what is this here? Cook Islands. Here's New Zealand. Here's New Zealand. Here are the French Polynesian Islands, Moorea, where I sat and looked at the clouds. And this is the Cook Islands. As we rotate and the Earth wobbles, we go through a 15-degree wobble underneath this stable air mass. This is a stable oceanic air mass. There's very little in there in terms of a land mass to alter through mountains or through landmass temperatures the stable air masses. Now when we roll up into this stuff and spin, we're actually under a stable air mass here. Now this isn't actually as simple as a low and a high system, which is what you see in the weather, because one thing that you should be aware of is that our planet is rolling. It is wobbling 15 degrees quite suddenly at times. You have landmass alterations in land speed. Sometimes you're moving fast, sometimes you're moving slowly. When we wobble quickly and suddenly 15 degrees shift, boom, we're up here. This is stable, and these clouds that you can see here are convection clouds. It's hot, it's equatorial, they evaporate, they go up, they precipitate into droplets. You can see cumulus clouds, and they look like big tall clouds with big round bits at the top. When they are over your city down here, you know you've actually broken the cohesive relationship with your upper air masses above your place and gone under cohesive structures in this place, and they've turned up down here because your planet's rolled underneath them. And it's quite different, very, very different concept from a rotation of a flat circular air mass that's cohesive and spinning with a stable spinning planet, which is not happening. We don't have a stable spin because this ice up here has melted. This stabilized our spin. It is now melted, and now it is part of this ocean. So what you've got is more water in the system and less ice. That means that when you are looking at your coastline and it is disappearing in South Africa on the down here, your river deltas are filling up, you're getting more water. That's because you've melted your poles with your grid, North American grid, Chinese grid, Australian grid has heated the whole thing up. This is probably a sun-driven or an orbit-driven change. It's an oscillation that's almost predictable. It goes up and down every 8 or 9 years. It can change. Some of the things that are going to change it is that the planet is wobbling because we've lost the pole ice. We've lost a lot of ice on mountains. We've lost a lot of ice on mountains. And now we've got more water in the system. And so it evaporates and it comes back down again as rain. It's raining now. When you spin, you get a lot more water at the equator because it throws it out at the equator as it spins. So you're going to have a loss of land. Perhaps you'll lose land here because you're going to have more water here. Perhaps some of your islands will lose a little bit of land. Coastal areas and in places like this in the Mediterranean where you've got water coming in here or here, you're going to lose land. Maybe here around the Black Sea, there. Maybe you'll lose a little bit of land here. Maybe this water will come and pump in underneath these two islands here. Maybe you'll lose a little bit of land here or in here or even here. Because this is melted, we've got a lot more moving around in this area here, and we're wobbling 15 degrees in and out of colder air and warmer air structures. As the warm air structures suddenly are here, they're going to be impacted by these cool currents, and it's going to mix up and it's going to rain. As we wobble in and out of cold and warm air fluxing, it's gonna rain. It's raining now. Okay, so that is what is happening with your weather. It has to be related to your marine situation because we've got cold currents down there. We've got warm currents in the middle. We've got a slight change with El Nino and La Nina that actually has a huge impact on this area here because this floods at La Nina. It gets really wet, not a little bit wet. Okay, and then when your planet wobbles because you've lost that polar ice cap and you've lost a lot of glaciers, you've lost a lot of snow, what you've got is a problem because you're going back to the Pleistocene, aren't you? You've got more water, less ice, and you're going to lose your river delta areas. You're going to lose some of your land. You're going to have to lose it because it's going to get wetter. We've got more water moving around and we're wobbling. So when you're talking about your weather cells, you should talk about the fact that the planet is wobbling and that the ice has melted. These are important things, and when you're talking about La Nina and El Nina, these things are current driven. They are marine driven. It is not something that is a maybe. It is a standard oscillation, and it is related to the ocean temperatures and tongues of ocean currents that are colder or warmer. It's pretty simple. It's not bizarre or unknown or weird or maybe or what's going to happen next, we don't know. It's something that's pretty standard. It oscillates on a pretty standard feature. We've been measuring it for a long time, and we've got oscillation information that supports that we are in a fairly standard oscillation with that. Now, this is a marine scientist talking. This is a marine surface current map. It's not always accurate. The bathymetry is wonderful when you get into the bathymetry. If I could show you that, it would be awesome because I'm not sure where that is. Oh, here it is. Here's the trench. This is a big trench, South America, North America. A big trench that funnels that water up here, and then this is a ridge that's spreading because of magma that's rotating this way and this way. This trench funnels the water west from there to give you that La Nina El Nino swap. Okay, that is what happens there. This is the ocean floor. Isn't it fantastic? It's a great map. Have a look at it. Okay, adios amigos.